Hello everyone. Today I will be presenting my machine learning project focused on solving a critical problem in e-commerce, inventory management. My project is titled Daily Production Forecasting to Optimize E-commerce Stock Levels. I will walk you through the opportunity evaluation, the business understanding using the CRISPDM framework, my validation plan, key system design decision, and finally the potential risk in production. Let's get started. First, opportunity evaluation. The problem is clear. E-commerce sellers consistently struggle with having either too much or too little inventory. Stockouts lead to lost sales and unhappy customers, while overstocking ties up capital and increased storage costs. This is an attractive opportunity for an ML solution based on three criteria from Module 1. First, high ROI. Second, data availability. And third, automation. Second, CRISPDM business understanding. In the CRISPDM framework, I started with business understanding. The problem is to predict the optimal daily production or stock replenishment quantity for each SKU to meet the anticipated amount without creating excess inventory. Success will be measured by two types of metrics. Outcome matrix, this measures business impact. Our goal are 20% reduction in stockouts rates and a 15% reduction in excess inventory holding costs. Output matrix, this measures model performance. The primary metric will be MAP, where we will target value less than 10% for our demand forecast. Relevant factors that our model must consider include historical sales data, product price and promotion, seasonality, day of the week, public holidays, and the life cycle stage of our products. For example, is new, trending, or being phased out. Thirdly, solution validation plan. Our solution concept is a machine learning model that uses time series forecasting to predict daily demand for each product. To validate this, I propose a three-stage iterative plan. First, a pilot study. We would partner with a small group of sellers, say 5 to 10, to run a historical backtest. We'd train the model on their past data and simulate how our predictions would have performed against their actual performance. Second, an A/B test for sellers who are interested. We'd deploy the model for a subset of their products and compare the stockouts and overstock rates against a control group where they use their current method. Thirdly, user feedback interviews. Throughout the process, we'd gather direct feedback from the sellers to understand the usability of the tool and refine the features that matter most to them. Fourth, ML system design. For the system design, I've made three key decisions based on Module 4. First, on batch versus real time. This will be a batch processing system. We don't need real time. Second, by prediction. Running a daily job overnight to generate forecasts for the next week is perfectly sufficient for inventory planning. Second, on cloud versus edge, this will be a cloud-based solution. It centralizes data from all sellers, allows for scalable computing power for model training, and makes it easy for delivering predictions back to sellers through a web dashboard. And third, on human in the loop, this system will be human augmented. The model provides a recommended stock level, but the final decision rests with the seller. They can easily override the solution based on their unique knowledge, like an upcoming influencer campaign that the model isn't aware of. 5. Potential risk in production. Finally, we must anticipate potential risk in production. The biggest risk is data drift. A product's demand can change suddenly due to a viral TikTok video or negative news story. Our model trained on historical data won't immediately recognize this news pattern. To mitigate this, we'll need to monitor for a sharp increase in prediction error and have a process to maintain the model or flag anomalies for human review. Similarly, concept drift is a concern. Long-term trends like a permanent shift in consumer behavior post-pandemic can make our model's assumptions outdated. We will combat this with scheduled periodic retraining of the model on recent data to ensure it adapts to a new normal. Other issues include latency in the batch pipeline, which we will monitor and ensure the quality of incoming data from sellers, which we will handle with robust data validation check.